Welcome to lecture series on EPG Padasala for Computer Science. In this lecture class, we will be discussing software testing. Learning objectives: outline the need for software testing, address how software testing can be used for assessing and improving software quality, explain how test cases can be generated, outline the different testing techniques. Testing is a process of identifying defects, develop test cases and test data. A test case is a formal description of a starting state, one or more events to which the software must respond, the expected response or ending state. As an example, let us consider a banking application. All of us use automated teller machines. Let us consider the operations that we perform on an automated teller machine. Operation 1: as an user of the automated teller machine, you insert your card. The card reader scans the card and the card number will be given as input to a process validate card. The process or operation validate card must check whether the card you have inserted is a valid card or not. If it is a valid card, you must be asked to enter the personal identification number. If it is an invalid card, a message must be popped up on the screen stating the card is invalid. So, for this operation we have two test cases. One test case is a valid card number, another test case is an invalid card number. If your card number is valid, as I have mentioned, you will be asked to enter the personal identification number. This number has to be validated. Let me name the operation as validate PIN. So, the input to this operation will be your card number and PIN number. The operation checks in the database whether the PIN number you have entered is valid or not. If it is an invalid PIN number, appropriate message has to be popped up. If it is a valid PIN number, you should be asked to select an option from the screen, meaning that a pop-up menu will be popped and you will be asked to select balance enquiry, deposit, withdrawal or other operations. In the case of validate PIN operation, here too you should have test cases for both a valid PIN and an invalid PIN. So, for each operation you perform, whether it is deposit, withdrawal or balance enquiry, appropriate test cases have to be generated and recorded. So, to state, when you are documenting the test case, you will have the input for the test case, anticipated output, actual output, inference which may be pass or fail, then corrective action which may be done by the programmer if your test case fails. That is why we have defined test case as a formal description of a starting state, one or more events to which the software must respond, the expected response or ending state. Test data is a set of starting states and events used to test a module, group of modules or entire system. A module performs a well defined task. Module has input, process logic, output. A module can be individually tested. Testing begins at module level and works outwards towards the integration of entire computer based system. Different testing techniques are required at different points in time. Testing must start at the programmer level itself. Only then the product which is developed can be delivered in time. We are aware that each module performs a well defined function. A module must be implemented in an incremental fashion, so that for each increment test cases can be executed. Fault localization becomes an easy task if a module is implemented as increments and tested as increments. Once a functionality is realized, write test cases to check whether it works. If it does not work, you can fix the fault easily. Instead, if you are implementing all the requirements and then testing the module, fault localization becomes a tedious task. Testing is conducted by the software developer and independent test group for large projects. Testing and debugging are different, and debugging is essential in any testing strategy. A strategy for software testing integrates the design of software test cases into a well planned series of steps that result in successful development of the software. Testing can be non-execution based testing or execution based testing. When I mean non-execution based testing, reviews, walkthroughs, inspections can be non-execution based. Without testing the software, the tasks that are carried out can be reviewed and inference can be drawn. When we talk about execution based testing techniques, the programs are executed, appropriate data sets are used, or I can say appropriate test cases are used, and inference is drawn. The strategy provides a roadmap that describes the steps to be taken, when and how much effort, time and resources will be required. The strategy incorporates test planning, test case design, test execution and test result collection and evaluation. That is what I said: input, anticipated output, actual output, inference, corrective action. For each module, a programmer or the individual or independent test group will prepare a set of test cases from the software requirement specification document, which will contain the input, anticipated output. Then these test cases are executed. The actual output is recorded and evaluation is made whether there is a deviation from the anticipated output and actual output. If there is a deviation, reasoning is done, a what if analysis is performed, and an inference is drawn why the deviation has occurred, and appropriate corrective action must be taken. The strategy provides guidance for the practitioner and a set of milestones for the manager. Milestone is nothing but completion of significant events in the software development life cycle. Because of time pressures, progress must be measurable and problems must surface as early as possible. So, at each stage of the software development life cycle, measurements play a major role. In requirements analysis phase, design phase, coding phase, testing phase. Of course, after deployment too. During the testing phase, number of errors detected, number of errors corrected, all these play a major role. Unless the software is tested thoroughly, we cannot deliver a quality assured software product. Verification and validation. Software testing is part of a broader group of activities called verification and validation that are involved in software quality assurance. Verification are the algorithms coded correctly, set of activities that ensure that software correctly implements a specific function or an algorithm. Validation, does it meet user requirements? The set of activities that ensure that the software that has been built is traceable to customer requirements. We are aware when the software is built, we have to appropriately capture the functional requirements given by the customer. If there is a deviation, correctness attribute of the program gets affected. That is one reason why verification and validation activities has to be carried out. Organizing for software testing, testing should aim at breaking the software. Common misconceptions: the developer of software should do no testing at all. In practice, if a software developer is not testing the product he is developing, testing by an independent test group or other individuals will be a tedious process. In fact, it is the responsibility of the programmer to test whether he or she has implemented the functional requirements as per the software requirement specification document. We are aware that software requirement specification document is the legal contract between the client and the developer. Only if the programmer who is coding the module executes test cases for each increment of the program, the module he or she developed can be easily tested by other individuals or an independent test group. Of course, the software should be given to a secret team of testers who will test it unmercifully. This is one more common misconception. The testers get involved with the project only when the testing steps are about to begin. If the testers are getting involved in the project only when the testing steps are about to begin, the individuals who test the product may not be fully aware of the functional requirements. They will have to allocate time to carefully understand the functional requirements specified in the software requirement specification document, and they will have to proceed with testing. If the testing team or individuals who are involved in testing is involved in the project from the early stage, testing becomes a simpler process. Reality independent test group removes the inherent problems associated with letting the builder test the software that has been built, removes the conflict of interest that may otherwise be present, works closely with the developer during analysis, and design to ensure that thorough testing occurs. Levels of testing for conventional software: unit testing, integration testing. Unit testing concentrates on each module, component or function of the software as implemented in the source code. We are aware that while designing, we adapt a divide and conquer strategy. Architectural design, we identify the modules and relationship among the modules. Each module can be developed independently by different programmers. So, unit testing concentrates on testing each module. Integration testing focuses on the design and construction of the software architecture. Validation testing, requirements are validated against the constructed software. System testing, the software and other system elements are tested as a whole. Unit testing exercises specific parts in a component's control structure to ensure complete coverage and maximum error detection. Components are then assembled and integrated. Integration testing focuses on inputs and outputs and how well the components fit together and work together. Validation testing provides final assurance that the software meets all functional, behavioral and performance requirements. System testing verifies all the system elements, software, hardware, people, databases mesh properly and that overall system function and performance is achieved. All of us are aware that today most of the applications are web enabled. So, your application program is involved, a database server may be involved which may be in a remote site, application servers are involved, communication network is involved. When you look into the interconnecting devices, you may have repeaters, hubs, switches, routers, gateways involved. So, from a system testing point of view, you have to verify that all the elements which I have specified, the software, the hardware, people, databases, the communication networks that is used to interconnect your servers function properly and performance is achieved. When you perform a unit testing, the program or the module is individually tested, checked whether it satisfies the functional requirements or not. Once integration of modules is complete and the product has to be deployed, you will have to verify whether all system elements put together will work. Most cases in practice during the system testing phase, lot of bottlenecks are faced and you need expertise from different domains. When you talk about your coding phase, the expertise required will be from the programming domain, or you would have identified the right person for performing the program with respect to the programming environment. When you come to system testing, as I have mentioned, expertise from programming is required, expertise with respect to your hardware environment is required, expertise with respect to your networking environment is required. because during your system testing phase, lot of issues like malfunctioning of your program unable to realize the requirements properly occurs. So, identifying the appropriate reason is required. Assume you are trying to reserve a ticket using irctc.co.in. You are unable to connect to the database server. You have to identify the reasons, whether the problem is with your application program or whether the problem is with your communication network. It has to be fixed and appropriately corrected. System testing in general is done by a team with expertise from programming, computer hardware and communication networks. When is testing complete? There is no definitive answer to this question. Every time a user executes the software, the program is being tested. Sadly, testing usually stops when a project is running out of time, money or both. You have to deliver the product within the schedule, or already there is a schedule slippage. You will have to stop the testing process and deploy the product. One approach is to divide the test results into various severity levels. Then consider testing to be complete when certain levels of errors no longer occur or have been repaired or eliminated. Ensuring a successful software test strategy, specify product requirements in a quantifiable manner long before testing commences. State testing objectives explicitly in measurable terms. Understand the user of the software through use cases and develop a profile for each user category. Develop a testing plan that emphasizes rapid cycle testing to get quick feedback to control quality levels and adjust the test strategy. Build robust software that is designed to test itself and diagnose certain kinds of errors. Use effective formal technical reviews as a filter prior to testing to reduce the amount of testing required. Conduct formal technical reviews to assess the test strategy and test cases themselves. Develop a continuous improvement approach for the testing process through the gathering of metrics. More on unit testing focuses testing on the function of the software module, concentrates on the internal processing logic and data structures, is simplified when a module is designed with high cohesion. A module must have high cohesion, low coupling, reduces the number of test cases, allows errors to be more easily predicted and uncovered. These 2 points are valid only if your module is highly cohesive. Otherwise, the number of test cases will increase. Concentrate on critical modules and those with high cyclomatic complexity when testing resources are limited. Targets for unit test cases: module interface. Ensure that information flows properly into and out of the module. Local data structures. Ensure that data stored temporarily maintains its integrity during all steps in an algorithm execution. Boundary conditions. Ensure that the module operates properly at boundary values established to limit or restrict processing. independent paths, basis paths. Paths are executed to ensure that all statements in a module have been executed at least once. Error handling paths ensure that the algorithms respond correctly to specific error conditions. Common computational errors in execution paths: misunderstood or incorrect arithmetic procedures, mixed mode operations, example int, float, character, incorrect initialization of values, precision inaccuracy and round off errors, incorrect symbolic representation of an expression int versus float, comparison of different data types, incorrect logical operators or precedence, expectation of equality when precision error makes equality unlikely, incorrect comparison of variables, improper or non-existent loop termination. Other errors to uncover: failure to exit when divergent iteration is encountered, improperly modified loop variables, boundary value violations. Problems to uncover in error handling: error description is unintelligible or ambiguous, error noted does not correspond to error encountered, error condition causes operating system intervention prior to error handling. Exception condition processing is incorrect, error description does not provide enough information to assist in the location of the cause of the error. Drivers and stubs for unit testing: driver, a simple main program that accepts test case data, passes such data to the component being tested and prints the returned result. Stubs serve to replace modules that are subordinate to, called by the component to be tested. It uses the module's exact interface, may do minimal data manipulation, provides verification of entry and returns control to the module undergoing testing. Drivers and stubs both represent overhead. Both must be written but do not constitute part of the installed product. Summary: software testing plays a major role in delivering a quality assured software product. I acknowledge the authors of the book which I have referred and the web resources I have used for this presentation. Thank you.